Okay, I left off in the last video talking about what correlations are like, their range, what they kind of look like in scatter plots, and talking about some correlations that are kind of obviously meaningless, right? That are just kind of spurious. So it's useful to know what variables are related to each other so we can predict values of one from values of another. However, we can't look at causation by looking at correlations alone. We can't say that X causes Y or A causes B just because those are correlated with one another. And this is summarized in a very succinct idea that you've probably heard before, and you're definitely going to hear it more. Correlation does not equal causation. Just because two things are related doesn't mean one of them causes the other. If you observe any correlation, let's say between variable A and variable B, it might be that variable A causes variable B, sure. It might be that variable B causes variable A, could be a reverse causality. It might be that some other variable, a third variable, causes both of them, C causing A and B, or it might be that there's just no meaningful relationship at all, like in those spurious correlations I showed you before. So you cannot base any causal claims off of simply running a correlation. The classic example people use of this is the idea that ice cream sales and violent crime both rise in the summer. So is it that violent crime is causing ice cream sales or the other way around? Well, no, it's that both of those things are more likely to happen in the hotter months when more people are outside, perhaps frustrated by the heat. So heat is actually the third variable in that correlation that's causing both ice cream sales and violent crime to rise. So there's oftentimes another explanation for why a correlation might be there. So if we can't look at causation, why do we do this? Well, it still helps us with description and prediction. We still can predict values of one variable from values of another if that relationship is consistent, even if it's not causal. It might also be that you can do a correlational study more easily than an experiment, and you are providing kind of preliminary evidence to say that one of them causes another, and maybe even show that evidence in a situation where you don't have enough control to run an experiment. But ideally, to show causation, you're going to run what's truly called an experiment. And I say that because I think a lot of people use the term experiment just to refer to any type of scientific study. And that's not true. All of those things we've talked about before, naturalistic observation, participant observation, case studies, correlations, survey research, those are all study designs. They're not experiments. Experiments are studies in which an investigator excuse me, manipulates at least one variable and then measures the other variable. So they manipulate what's called the independent variable to measure if that affects change in the dependent variable between different groups. So the experimenter is doing something to manipulate the environment or the situation or information or some type of stimuli that the participants or respondents are being exposed to see if that manipulation changes something about their thoughts, feelings, or behavior. I've mentioned these terms already, but the independent variable is the one the experimenter is changing or controlling. So they're manipulating this independent variable. The dependent variable, well, you can remember that, is that the dependent variable depends on the independent variable. The dependent variable is the one that's being measured. It's the outcome, like a grade or an emotion or a behavior towards someone. So the way that you want to think about this is that the independent variables are hypothesized to cause change in the dependent variables, right? And experiments have a lot of different features. Almost always they're going to have different experimental groups where one of them is receiving a different sort of treatment from the other. The experimental group or the treatment group is the one that's getting some sort of unique condition that the study is designed to test. You might often compare this to a control group. They're going to be treated exactly the same as the experimental group, except they're not going to receive the same independent variable level. Maybe it's a control group where there's a complete lack of stress or a lack of information that they're getting compared to this experimental group. Experiments don't always have control groups, though. It's not that you always want to have the absence of a variable, because a control group with the absence of a particular variable might not be very realistic. For example, if you want to see a study that people in my research methods class have done before, if the presence of a tattoo makes someone more attractive. Well, you don't show people a picture of someone with a tattoo and then show a control group a picture of nothing, right? You show them the picture of the person without that tattoo. So you still have some kind of stimulus, but it's not the same as the experimental group. So control groups still are useful, but they're not always happening because you might not be able to remove all the relevant factors there. Confounding variables, something to remember, are uncontrolled variables that change along with the independent variable. So if you are trying to induce stress, for example, it might be really hard to manipulate stress without manipulating something else, like the time pressure that people have that limits their ability to answer a certain number of questions, right? So anything that systematically changes with your independent variable manipulation is something called a confound. I mentioned control when I talked about the scientific method, and control is how much internal validity you have in your experiment, basically. You're keeping things completely consistent in a study except for that independent variable change that you're making. So the internal validity of your study is that control and the idea that you're able to very confidently say that A is causing B, because I've kept everything else completely consistent. And if you have very high internal validity, you can determine that there's a causal relationship there. A is causing B. Unfortunately, there is a trade-off between internal and external validity. When you maximize control, or internal validity, you are reducing the naturalistic features of a study, and you're perhaps making it less generalizable. So these things are in kind of a seesaw, counterbalance type of relationship where you can't really maximize both of them. One is going to go down as the other goes up. So there are trade-offs here that, like, observational studies are going to have much more external validity, not very much internal validity. Experiments have a lot of internal validity, but much less external validity. Experiments hinge on the logic behind something called random assignment. Earlier, I talked about random sampling in the context of survey research. Random sampling, remember, was drawing a random subset of people from a population with the assumption that that is going to make them representative of that population. Random assignment is different. You can use any sample in an experiment and still use random assignment, including a convenience sample, which we talked about. But random assignment is this idea that every participant in your study has an equal chance of being assigned to any of the conditions that you have put together, and of any of those levels of the independent variable. This is going to reduce the likelihood that demographic things or individual differences or personal circumstances about those participants are going to influence that relationship between the IV and the DV, the independent variable and the dependent variable. So if you randomize the assignment of people to different groups, then you can assume that those groups are equivalent with respect to all those other demographic and individual intelligence and cognitive types of characteristics. It also helps you, because it does this, limit the influence of third variables. I mentioned that example where third variables might be causing two different variables to rise, right? If you're randomly assigning people to different groups, controlling for all those different influences and seeing how the independent variables influence the dependent variables, you're ruling out those third variables and other extraneous variables. So remember that random assignment is this almost kind of magical thing that lets us do experiments and determine if there's a causal relationship between things, and that's different from random selection, which is about how you're drawing your sample from a particular population. When you're running an experiment, it's important to remember that, in psychology, you're dealing with people's understanding of the situation and their behavior that's influenced by it, right? So the expectations that people have in psychological studies and experiments can influence the outcome. And this is true for the experimenters and the people participating in the studies, even if they're trying not to do it. So, experimenters, for the most part, are trying to be objective, but we might be doing things when we're running a study that unconsciously indicate what we want from a participant or what condition that they're in. So, let's say you're assigning people to either be treated nicely or poorly or something. The experimenters might be going over the top or somehow indicating to the participants the types of behavior they are expecting. And participants, in turn, are affected by these things that we might call demand characteristics, these cues that participants are getting either from the materials or the experimenters that indicate to participants what they're supposed to be doing. Supposed to maybe should be in quotes. Because the goal of an experiment is that people are, behaving in a natural way in response to the independent variables they're being presented with. But sometimes in studies, participants want to be like good participants rather, and do what's expected of them. And that's not very naturalistic, right? That's very artificial and might not be a fair way of testing our hypotheses. So some ways to get around these are by doing single-blind or double-blind studies. Single-blind studies, either the participant or experimenter is unaware of the condition they're assigned to. This is almost always true of participants, that they don't know what condition they're in or what the alternatives are. And sometimes it might even be true of the experimenters. When it's true of both the participant and the experimenter, this would be called the double-blind study. This is more difficult and time-consuming and resource-consuming to do because you need someone like an assistant or another researcher that doesn't know as much about the study to carry out the experiment. So this is done less frequently because it just takes more resources, but it does help reduce the bias from experimenters and the demand characteristics that participants might pick up from them. You might be familiar with another way we might limit the effective expectations from how people talk about medical research or clinical trials. Placebo effects, right? The idea that some sort of treatment should have an effect, so people might experience that effect, whether or not the medication or therapy or whatever was useful. So placebo effects are the idea that people's expectations lead them to believe that they're improving or having some kind of positive effects. So if you give people a placebo, a fake sort of medication, for example, in one condition and a real medication in another, then you can see if there's actually a difference and rule out the idea that people are just thinking that they're getting better, right? There are also kind of the opposite of this, something called nocebo effects. Like when you tell people that they're going to have some bad side effect from a medication, like they're going to be tired or nauseous, they might feel that way just because they've been told they're going to feel that way. So giving people a fake medication might also help figure out negative effects in addition to positive effects. Okay, on this last page for the study designs, I just have kind of a summary here. I'm not going to go through it now, but I think this is kind of useful to go through when studying or reviewing these things, to think about the different purposes that descriptive, correlational, and experimental designs have, and the different tactics that we might use to go through them. And then in the last video for this unit, I'm going to talk a little bit about research ethics, a little bit about the history of human subjects research, and some more recent examples.